Hey guys, so here's part 3 of the 5.4 day 1 notes. We're continuing to factor polynomials. Number 7, we have x to the 4th plus 7x squared plus 6. Well, let's see if these three terms have anything in common. They don't. The only number they have in common is 1, and they don't all have variables, so we can't take that out. Okay, so these type of problems where you have a trinomial, and notice we have a 4 and a square. This is going to be a special type of factoring. We're actually going to factor this similar to a quadratic. Okay? So we're going to do two sets of parentheses. And since our a value, so the number in front of the x to the 4th is 1, all we need to figure out are what numbers that multiply to 6 and add up to our middle term. So we usually do this when we have like our ax to the 4th plus bx squared plus c, or if we have something like ax to the 6th plus bx to the 3rd plus c. So if you ever have something like these two, always make sure you factor similarly to a quadratic. So I'm going to have my two sets of parentheses, and instead of doing like x and x, we're going to have x squared. Okay? So now let's figure out what are numbers that multiply to 6. Well, we have 1 and 6, 2 and 3. Which pair adds up to a 7? Well, that's going to be 1 and 6, right? And to add up, we need to make sure both of these are pluses. Now, let's see if we can factor any more. Well, with the x squared plus 1, we can't. This is not a difference of squares. Remember, it's addition. And then x squared plus 6, we can't factor that either. Notice we have addition, and 6 is not a perfect square. So this is not a difference of squares. So actually, this would just be our final answer. Okay? So just be careful on those. Those are very simple because that's all you have to do. But just also be careful if you get that x squared minus a perfect square, factor that out just a little bit more. Okay, let's go ahead and do our next one here. Okay, so our last one's going to be, once again, another special type. Okay, now first of all, before we get into it, let's see if these two terms have anything in common. They actually do. They both have a 2 and an x squared in common, so I can take that out. So I'm left with 8x to the cubed minus, I think this is 125, yes. Okay, so now our next special type you can see is, once again, we have a lot with binomials that are special types. But so this is a binomial. Notice we are subtracting, okay? Now we have x to the cube, so this is not a difference of squares, because remember that would be something like x squared or x to the 4th. But with the cube, this is what we call a difference of cubes. So in order to be a difference of cubes, 1, you have to be a binomial, as we see. 2, you need to make sure you're subtracting. And 3, you need to make sure that your a and c values, so the numbers in the number in front of the x cubed and your last number, they're perfect cubes. Now you might be wondering, how do I know my perfect cubes? Well, remember, you can take any number. So let's say we take 1 and take it to the 3rd power. Well, 1 to the 3rd is just 1. What about 2 to the 3rd? And you plug this into your calculator, that gives us 8. Okay, what about 3 to the 3rd? That's 27. 4 to the 3rd, that is 64. 5 to the 3rd, that's going to be 125. So just taking any number, that gives you your perfect cubes. So let's say you're like, well, okay, what if it's a large number? I'm not going to want you to do that. Well, another way is you can use your calculator to figure out all your perfect cubes. Remember, all you have to do is you can go, if you're using the graphing calculator, you can go into math, and then it'll be number 4, and then just put a number in. And if it's an integer, of course, that's a perfect cube. If not, then it's not, okay? So that's something you can use as well. Okay, so notice 8 and 125, they are numbers on our perfect cubes list, so they are perfect cubes. So what we need to do is take the cube root of 8 and take the cube root of 125 to determine our a and our b values, okay? So the cube root here is going to be 2x, and then our cube root of b is going to be 5. Now here's the formula you're going to follow for a difference of cubes. We're going to have a minus b, then a squared, plus ab plus b squared. So that's why I'm using a and b to reference those, okay? So as I said, you take the cube root of your a and the cube root of your b to get those values, okay? So our cube root of 8 and x is 2x, and our cube root of 125 is 5. Now we plug this all into our formula. Don't forget to bring down the 2x squared, because we need to have that as part. So our a minus b, that's going to be 2x minus 5. And then a squared. Now when we do a squared, you need to do 2x and square that whole thing. So that's actually going to give us 4x squared. We do 2x times 5 to give us a 10x. And then our last one is we're doing 5 squared, and that's going to give us 25. Okay? And so we can't actually really factor anything else. So we can't really factor anything else, so this will be our final answer. So if you do get a difference of cubes type of problems, make sure you use this formula. It will definitely help out when you're doing the problems. Okay, make sure if you have any questions, you contact me, and make sure you work on the homework assignment. I'll see you guys later.